There is one technique in subarray problems where we have the cumulative sum of an array of each index of an array, then we can get the subarray. So basically, if we have cumulative sum of each index, then we can get sum of subarray. But I notice sometimes there are some details that are glossed over. I want to speak about that today. So for instance, let's create this scenario. Say we have this, and let's say this I and J, this subarray, right? So we want to get this. So the solution that is often presented is this, that this is J, and then you have this is I. So now if you want to get ij, you can get sum of ij by subtracting sum of 0j, sum of 0 I minus 1. Well, minus 1 here is important detail because we want to subtract all that is before I. That's why we are subtracting from I minus 1 and not I. So this is the target sum, right? And then at this point, as the explanations mostly go, they say, oh, look, this is the two-sum approach. This is just like two-sum array, and they don't quite explain this problem in terms of this problem. They take it in terms of two-sum because they are familiar with that problem space and they gloss over it. Often at least the tutorials that I have seen or the documentations, they do that over there. So I thought I would look into it and will try to make sense of it and try to explain it in terms of this problem, its context, right? So now from this, you can understand that I minus 1 would always come before j. So we can write this 0 I minus, which is basically rearranging from 0j minus target. Now what does that give us? That tells us if this is going to be true for a target value, right? And this value, then this value would always come before j. So in an array, I would always come before j. So if we were iterating through this, we would have passed this I value, right? Having said that, how can we tell quickly that we have seen it? And if you have worked with that, the solution is map. if you keep setting this previous cumulative solutions in a map, then you would be able to quickly tell whether you have seen this or not. So now your job will be to iterate through the array and plug these values, whatever these are, into the cumulative sum of j. So first you'll have the cumulative sum and then you'll plug it in and then you'll do the calculation and you'll come up with a number. Then you'll check whether this number is something that we have already seen. Now, how do we determine we have seen something or not? We do it using the map. Now, on each iteration, we would store the cumulative sum to the map. Why? Because we are storing it for the next iteration. So the next iteration would do this math on its end and be like, okay, have I seen this cumulative sum before? If it has, then that means uh, we can plug that here, right? And we can plug whatever, we can plug the rest of it here, which we are already doing, right? And then this condition satisfies. And when this condition satisfies, what happens? Well, at that point, we have found this configuration. Basically, now since we are accessing these, right, at this point, at least we're saving this. That's where we have the opportunity to save the index as well. Now, when we saved it in the map, we could have saved 0 index or I. We could have saved whatever the value of the I was. But this equation tells us that when we, this would give us I minus 1, right? So that means once we get the I minus 1, we'll have to increment that by 1. Why? Because we are not looking for I minus 1, remember? We were looking for I plus j. So that is one solution I have, and I have tried to, like, from the equation I tried to reason that why do we need map, because we need to see this previous value and we need to verify if it exists or not. If it does exist, then we get the index, but at the same time we know this is I minus 1, but we were looking for I. That's why we increment this by 1. So there is that. And yeah, once we find this, we just return it. There might be other pairs that satisfy this condition, but we don't need to keep looking for those. But I think this explanation has helped me understand it better, instead of like just at this point or this point saying that, oh, it looks like two summer question, and let's leave at that. So I don't want to blindly just apply that. I wanted to explain this thing. So is that